Okay, so if we carry on looking at the second half of the steam table book, so this is after we finished the previous video on page 11. If we carry on with page 12, we now get information about things other than water. So I'm going to go through this hopefully fairly quickly. So we'll start with mercury. So again, there's a pressure, temperature, specific volume, and enthalpy and the entropy. We can move on to ammonia. So there's refrigerants with exactly the same information. Refrigerant 12, the same set of information. There is some superheat on this, so instead of splitting this up into tables of the phase change and superheat, they put it all into one table. The same thing for refrigerant 134A. We then move on to another section where we have information of dry air at low pressure. So if we have a temperature from 175 to 3000, now this is Kelvin, so just make sure you see Kelvin and not degrees Celsius. You've got some CP values, some CV, again the viscosity and K, the Prandtl number, which we said we were going to ignore, as well as some other information on the right there for dry air at a low pressure. The next page we have some information on specific heat capacities. So the specific heat capacities in kilojoules per kilogram Kelvin of the gases of carbon dioxide, monoxide, hydrogen, nitrogen, oxygen, water, and then the C's. There's CH, C1C, 2C, another 2C, and then down to the bottom in the right, middle right, we have the 6 and the 8 value. Okay, so please note you've got the specific heat of various different gases on that page. The next page we have some other properties of molar properties of gases and vapors, and in all honesty we're probably not going to use any of this information for this course. Please note that it is here though, and you might need it for chemistry or physics or one of your other courses, particularly next year. The table, so that's the section at the top, we probably won't need in this course. The next section is on carbon dioxide and water vapor, so there's various information for those tables, but what I want to highlight is if you ever forget what the molar mass of carbon dioxide is, or of water vapor, there it is hidden on the table there. The next pages carry on, so again we're not going to be worried too much about these pages now, but depending on what you remember or not, we again have the molar masses of some values. Carrying on, we have some more gases, nitric oxide, hydroxyls, methane, and ethylene. And then we can go on to the next page, which has enthalpies of reaction and equilibrium constants, which are going to be more important for this course. So depending on the set of equations that you have, if you're trying to form carbon, hydrogen, different reactions, we get values for the enthalpies of reactions in this table here. So this is the values on this section here. So you will need to know that this is where you can find some enthalpies of reaction for this section. The last part on this table is the equilibrium constants. So the equilibrium constants in this bottom table on the bottom half of the screen at the moment. You might need this for chemistry. I don't know. Some of your equilibrium stuff or reactors next year. For this course, please remember it's here, but you probably won't ever need it in this course. The next page, and I've lost the page numbers unfortunately, is a section on chemical thermodynamic data. So we've got some information on carbons, hydroxyls, and things like that. Again, molar masses, so there's some molar masses of materials hidden in here. The rest of this information for this course is not actually valid, but please have a read through it. You might find some useful information for your, sorry, I lie, some of this information might come in useful later. Okay, so the enthalpy of formation is actually in there. So just double check what's in here, what's not. So you need to know what's in this completely and whether you need it for this year or for next year. The next page, which we now see, is page 23. There's various other information here as well. There's some CP values, there's a density, there are viscosities and K values again for various different materials. A lot of this information is repeated from the previous pages, but we do get some new materials popping up here. So I don't think we had sodium or potassium before, or a sodium-potassium mix. I think argon was there, I can't recall. And then the gases towards the bottom, you do have those values again. Because this was taken from different textbook sources, there is some repetition in the data down at the bottom here, but it puts it onto one table so you can compare it quite nicely. So that's page 23. On page 24, if you're ever interested to know what is the pressure if you're at the coast, so Z is the altitude above sea level. So if you are at the coast, the atmospheric pressure is 101,325. If you come up to Gauteng, or if you go into Everest, as you get higher and higher, what is the air pressure? If you're going all the way up to something 32 kilometers up, the pressure gets really low. So we've got the sets of pressures in this table. We also have some other information which I'm not going to worry about now because we don't use in this course. One of the other pages in this book which is fairly useful, there's a unit conversion page. So some of the odd ones that we often forget or we don't remember to this many decimal places. Mass, how many kilograms in a pound, you can use this textbook to, or this book to figure that out. Or the feet, some of the others are fairly simple. I hope you don't ever need to be reminded how many seconds in a minute, but if you do forget for whatever reason, it is there. So again, have a look here. What's a Kelvin to Rankine? The force, there's specific pressure information here. We can see how does the 4.186 towards the bottom here, how does the 4.186 value relate to kilojoules versus BTUs, and why is 4.1868 so important? Okay, so there's information on viscosity, and viscosity again dynamic or kinematic. The next page, there's some other information if you ever forget. So the first one that might be really important, sorry I've cut it off there, is the standard acceleration or the gravitational constant, 9.80665, or in different units. If you ever forget your equations for PV equals nRT, what is R? There's R, the universal gas constant, sitting in there, 8.3145. And there's even a unit conversion for you as well. There are some other calculations. Again, look through it. What is air made up of? How much nitrogen, oxygen, carbon dioxide? So typically we say 79% is nitrogen, 21% is oxygen, and then we typically ignore the rest. But if we want to be a little bit more accurate, there we've got the argon and carbon dioxide as well. And again, hiding through here, there's molar masses of various other things as well as the Stefan-Boltzmann constant. In a normal exam, if I don't give you information in a question, it's because it's hidden in this textbook somewhere, and you need to figure out where it is in this book. So please, when you're doing examples as well, if you tell me that the question is missing information, first step is to look in this set of data across this book and see what the steam tables and see what you can find. Okay. There are some other additional sources at the end of this book, but I don't think we actually need to worry about any of those because most of these have been transcribed into this book, and that is the end of this.